Hi everybody, I'm going over a couple of the questions. This is a few questions I'm going to do with you for chapter 3, which is 3.1 to 3.2 more practice worksheet. You will find this in the learning plan under week 18. So there is a front and a back, and you will just be writing these answers to these questions on your own sheet of paper. So again, it's in the week 18 learning plan. If you click on the day that we're working on here, you will see it attached there. Okay, let's look at question 1, 2, and 3. It says rewrite each degree measure in radians and each radian measure in degrees. It doesn't say to give the answer as a decimal, so this means you want to assume you're going to leave pi in your answers whenever applicable. Okay, so number 3 says negative 40 degrees. So I've just picked out some random questions that I want to do with you. Let's start with number 3, negative 40. And again, you're just going to write this on a separate sheet of paper. We learned that when we were converting, 180 degrees equals pi in radians. So what I'm able to do is I'm able to get rid of the degrees by dividing by 180. Pi is at the top. Okay, so what I have is negative 40 pi over 180. Now we need to reduce this. There's a lot of different things you could do. You could divide out the zeros and then divide them both by 2. You can simply use your calculator, again, whatever you're comfortable with. If you do it this way, negative 40 divided by 180, and then you just hit math, enter, enter, you can reduce it like that. If you had negative 2 over 9, if you had reduced it by dividing out the zeros, then negative 4 divides by 2, that would give you the negative 2, and then 18 divided by 2 is 9. So either way, it ends up being negative 2 over 9, and then you don't want to forget to put the pi back into the answer. So it'd be negative 2 pi over 9, or negative 2/9 pi. That would be okay as well. Okay, so 1, 2, and 3 will be like that. You're either going from degrees to radians or radians back to degrees. Okay, let's look at question 4. You have a tennis player with a certain swing. Okay, so let's write down number 4. There it goes finally. Tennis player's swing moves along the path of an arc. Okay, we talked about arc length in this section. If the radius of the arc circle is 4 feet and the angle of rotation is 100 degrees, what is the length of the arc? Round to the nearest tenth. Rounding means we are going to be putting pi into the calculator. The formula we used was S equals R theta. S is the arc, R is the radius, and theta is the angle in radians. So let's see what's given here. The radius of the circle is 4 feet. The angle of rotation is 100 degrees. Now that's nice that they give us the angle, but it's not in radians. So first you have to change it back, or I don't know why I keep saying back, I don't mean back. Change it to radians. If you want to, you could reduce this. The zeros would cross out and you're reducing 5 over 8 or 10 over 18, which ends up being 5 over 9 pi or 5 pi over 9. Or since we're going to be using the calculator, you can simply just plug it in. So I'm going to just do that. And I'm going to multiply 4 times 100 times pi, hit enter, and then I'm going to divide by 180. If you've forgotten how to put in the pi, you just type second and then this little caret key. There's your pi. So 4 times 100 times pi, I'm going to hit enter, and then I'm going to divide by whatever's in the denominator, which is just 180. So divide by 180. And it says to round to the nearest tenth. The problem with this one is 6.98 would round up, so it would be 7.0. So 7.0 would be your nearest tenths place. So the arc length equals 7.0, 7.0, and in this case, the label would be feet. Now in this section, we're rewriting each degree to radians and radians to degrees. Same thing that we were doing in section 1. If you look at this page, section 1 and section, this 1, 2, and 3, and 5 through 10, they're all asking you to do the same thing. You're just rewriting from one form to another. So don't put the pi in the calculator. You're just giving your answer as a fraction or as a degree. So we're looking at question number 8, and it says negative 7 pi over 3. Okay, so let's copy number 8 onto the paper. So I need to get rid of the pi, so I'm going to put the pi at the bottom, 180 at the top. Pi is going to cross out. So here's what you're left with. Negative 7 times 180. Hit enter, and then divide by 3. So negative 7 times 180. Hit enter, and then I'm going to divide by 3. So that gives you negative 420 degrees. And that's really what you're doing for that section. You're just going back and forth between those degrees and radians. Let's take a look at number 11. It's talking about a skateboarding ramp. Maybe some of you have been to a skate park and you've seen one of these quarter pipes. So it's just like a 1/4 of a ramp. You don't have the 2 sides of the ramp. That would be called a half pipe. This is 1/4 of the circle. The skateboard ramp at the right is called a quarter pipe. See how it's 1/4 of the circle. The curved surface is determined by the radius of a circle. Find the length of the curved part of the ramp. Okay, again, S equals R theta. We're looking for the S. The radius is 8 feet. Theta is nowhere to be found, or is it? Look at the picture. They show you that this is a right angle, and we learned that a right angle is 90 degrees. So this quarter pipe is a 90-degree angle like this. If it was a half pipe, it would be 180 degrees. So this one is a quarter pipe, it's 90 degrees. Well, again, 90 degrees isn't really that helpful because we need to have this answer for the angle written as a radian. So what I can do is just convert it. We want to get rid of the degrees. You're going to put the 180 at the bottom, put the pi at the top. If you want to reduce it, go for it. This 90 over 180 does reduce to 1/2 or pi over 2. You could write it like that. Or if you don't want to worry about reducing, since we're going to be putting it into the calculator, you can just simply write it as 90 pi over 180. Again, whichever, it doesn't matter. 90 and 180 reduced to 1/2 or pi over 2. Okay, now I'm going to type it into the calculator. 8 times 90 times pi, hit enter, and then divide by 180. Unless it specifically says to leave your answer in terms of pi for these story problems, then feel free to round it to the nearest tenth. Okay, notice I'm hitting enter, and then I'm going to divide by what's in the denominator. I have to double look, 180. So I'm going to divide that by 180. Okay, and you get 12.56, which we can round to 12.6, and I believe, yep, it's feet. So 12.6 feet. Okay, all right, that is number 11. So let's take a peek at the back of this sheet. The back side of the sheet has 14 and 15 where you're still finding the length of an arc. So that would be S equals R theta. And then you've got some variety problems here that are kind of different. We're going to do a couple of those. And then when you get down to the bottom, you are looking at the area of a sector. Area of a sector. Okay, so let's go ahead and do a couple of these on this side. Okay, number 16. How long does it take for the minute hand on a clock to pass through 2.5 pi radians? Number 16 is talking about how long does it take for the minute hand on a clock to pass through 2.5 pi radians. So I brought up a clock here, and I want to show you the difference between the hands that we're looking at. So this is an hour hand, this is a minute hand, the long one, and then this is a second hand. Not all of these analog clocks have this second hand, but it kind of shows you that there are 60 seconds, as you go around in a minute. So what I'm looking at here is this minute hand. As you move this minute hand around the clock, so you can kind of move this minute hand around the clock and you see what happens to the time. Okay, so let's say that I start up here. Notice it's 0. There's 5 minutes. Look at the time on the side. It says 8:05. This would be 10 minutes. This would be 15 minutes. So each one of these numbers is worth 5 minutes. So 5, 10, 15, 20, 25, and 30. Okay, so half of a clock would be 30 minutes. A full clock is 60 minutes. It's an hour. Okay, so each time we move around one full time, that's 60 minutes or it's an hour. If you go 5, 10, 15 minutes, so 90 degrees would be 15 minutes. If you go down here to this half an hour, that would be 30 minutes. This would be 45 minutes, so that's 270 degrees, be 45 minutes. And then if you go a full rotation, it's an hour. So I'm going to draw a couple of pictures here. Okay, so first I'm going to draw a circle. Again, for the clock, I'm just drawing a couple circles here. And we saw that if you rotate around, it doesn't matter which way you rotate. You know, a clock goes this way, but again, just the idea here. If you rotate around one full time, 360 degrees, that's equal to 60 minutes, or we just would say 1 hour. Okay, next think about if I'm rotating half of the clock. We saw that if we rotate half of the clock, again, a clock would technically go this way. It doesn't really matter. If I rotate half of the clock, I've rotated 180 degrees, and 180 degrees was half an hour, 30 minutes. Okay, the other thing that we saw was the 15 minutes. So again, a full rotation was all the way around. That was 60 minutes, an hour. If we did half of the clock, that was 30 minutes, and you can see it on the side going up to 30. There's 30. And 15 minutes is 5, 10, 15. That's 90 degrees of the clock is 15 minutes. If you go another 90 degrees, that's 30 minutes. If you go another 90 degrees, that's 45 minutes, and then you get up to the hour. So you can see I drew 90 degrees, and that would be 15 minutes. So now what I'm going to do is I want to figure out how many degrees I'm working with for number 16. It says 2.5 pi radians, but it would be much more helpful if I knew what that was in degrees. So I'm going to change it. I want to get rid of the pi, and I want to change it into degrees. So I write it with the pi at the bottom and the degrees at the top. I'm going to multiply 2.5 times 180. 2.5 times 180. Since those were my only numbers left. Again, look, 2.5 times 180. I typed that in and I got 450 degrees. So what I can do is figure out how much I've rotated around this clock, and that will tell me how much time has passed. Okay, so I'm starting with 450. Each hour, each time you rotate around once, you've rotated 1 hour. So every time you rotate around the clock one full time, it's equal to 1 hour. Okay, so let's take 450 and subtract out that full rotation. So 450 minus 360, one time around the clock, is equal to 90 degrees. Okay, don't confuse this with 90 minutes. This means we have 90 degrees left. Degrees, degrees. So if you look at these examples, every 90 degrees was equal to 15 minutes. So far I've gone 1 hour as I rotated around 360. I have 90 degrees left. According to my little cheat sheet here, 90 degrees is equal to 15 minutes. Okay, so this rotation, if I've rotated around 2.5 pi radians, I've rotated 450 degrees, which is 1 hour and 15 minutes. The last one that I'm going to look at here is number 17, and it's talking about a sundial. So let's look at a picture of a sundial. So here's some examples of a sundial. It's just simply a device that you have some sort of a middle point or a pencil or something. You shine the sun on it, and when the sun shines on it, it produces a shadow. If you are able to set this up correctly, this can predict pretty accurately the time of the day. And you may have to readjust the sundial for different times of the year. But you can make your own sundial. You can look it up on YouTube or whatever. And you can kind of predict what time of the day it is using this old-fashioned method. So we have a sundial that has a shadow, moves around every 15 degrees every hour. So what that's saying is if you are going 15 degrees, then you've moved 1 hour from whatever time you're starting at. If you start at 12, that means it's 1 o'clock. If you go 30 degrees, then that means you've progressed 2 hours. 45 degrees, 3 hours. 60 degrees, 4 hours, and so on. So every 15 degrees represents 1 hour of time change on that sundial. Okay, let's look at example A. After how many hours is the angle of rotation 8 pi over 5 radians? So let's go ahead and write down 8 pi over 5. Okay, now that's radians. What we need to figure out is how many hours will that be? Well, the directions for this sundial give us the hours of per degrees in degrees. So the first thing we need to do is change this back to degrees. Okay, so to do that, get rid of the pi, 180. The pi's will cross out, and you're going to be multiplying 8 times 180 and then dividing by 5. Okay, so I got 1440. I'm going to divide by 5, and I get 288 degrees. Now, this is not my answer. This is just the number of degrees. According to the directions, it moves 15 degrees every hour. So I can either subtract 15, subtract 15, subtract 15, subtract 15, or divide by 15 degrees. This will give us our number of hours. So 288 divided by 15 degrees for each hour. So that means we've moved 19.2 hours. So 19.2 hours. Okay, question B. What is the angle of rotation in radians after 5 hours? Well, each hour it's 15 degrees. So it's 15, it's 30, it's 45, it's 60. Really, you're just repeatedly adding 15. An easier way to do that is take the 15 degrees times the number of hours. So in this case, we are taking 15 times 5. So let's do that. 15 times 5 hours. And we're going to use the calculator. We can actually kind of predict it. Probably the next one should be 75. Let's see if that's right. And you can see that it does equal 75. And that was just the prediction from following this 15, 30, 45, 60, 75, and so on. So it's equal to 75 hours, or 75 degrees. Now, the question, though, isn't asking for the number of degrees. It's asking for the number of radians. So you're going to need to change it into radians. You want to leave the answer in terms of pi. So what I'm going to do is I'm going to take the 75 and divide it by 180. And then I'm going to reduce it in the calculator. To reduce, you can divide and then hit math, enter, enter. And you see that I get 5/12, 5 pi over 12. Okay, question C. A sundial has a radius of 8 inches. What is the arc formed by a shadow after 14 hours? Round to the nearest tenth. So I've got S equals R theta. And you can see that the radius is 8, and we're looking for the S, which is the arc. Now, what we don't know is the theta, or we don't know it directly. What we do know is that there are 14 hours involved. So we just used a formula a second ago that said if we take 15 times the number of hours, 15 was the degrees, times the number of hours, that will give us our angle. So this is going to be our theta. So I got 210 degrees. I need to change that to a radian. Remember, you can reduce this if you want. The zeros actually cross out. You can reduce it. But you can just put it in the calculator this time again. So I would just bring it over for theta. Okay, so now I'm going to type this in. I'm going to take 8 times 210 times pi, hit enter, and divide by 180. And you can see that I got 29.3 for this answer. And in this case, I think it's inches or feet. What are we got going on here? Inches. Okay, so this one would be 29.3 inches. Okay, so continue working on these two sheets. I will be posting up the answers. The rest of the answers, I'll do another video since this is more practice / review. I will post up the rest of the answers in another video later on this week. Have a great day.